We tend to ignore risks that are ever present in our daily lives. Take a car crash, for example. It may imply serious damage to our health or property. Precautionary measures can help to reduce risk. However, things are different when it comes to ecosystem management. Even though our well-being greatly depends on healthy ecosystems, we do not always treat them with appropriate respect. This means that we are constantly challenged by human-induced risks. International demand for timber and pulp by big industries has led to worldwide deforestation on an unprecedented level. Excess waste and pollution adds additional pressure to ecosystems that are already under threat. The clearance of forests in order to grow crops or graze livestock reduces biodiversity and essential ecosystem services, as well as the long-term capacity of the land to support farming at all. The problem is made worse by population growth. Combined, these activities push ecosystems worldwide to their limits. We are still trying to understand the complexity of ecosystems and the way they interact, while the negative impact of climate change continues unabated. But how much disturbance can ecosystems take before they collapse? No one knows exactly, just as we don't know how they respond to these disturbances. However, this very question is extremely important for the effective management of these ecosystems. This is where the Marisco management approach comes into play. Based on the CMP's open standards for the practice of conservation, Marisco stands for Adaptive Management of Risks and Vulnerability at Conservation Sites, and is designed to follow a proactive and risk-robust conservation approach. First of all, a working group, comprised of as many stakeholders as necessary, identifies the project's scope, encompassing all areas relevant for the planning and management of the project site. The next step is the identification and analysis of the biodiversity, constituting the elements of conservation. From these elements, ecosystem services are derived, for example, fresh water and food. The team then analyzes the likely processes threatening these elements, including future risks. To get to the bottom of these cause and effect chains, the underlying root causes are determined. This process is continued until a near-complete picture of the situation emerges. Finally, a classification into explicit domains, such as institutional, biophysical, and socio-economical factors, enhances the understanding of the share of the impact. A rating of individual elements is then carried out, using a variety of criteria, such as systemic activity, as well as the level of criticality over time. For this, the team evaluates the past and future status of each element, comparing them with current conditions. This enhanced understanding of the dynamics within these models can greatly contribute to proactive management. Why is this so important? Well, this exercise helps the team to identify key elements and possible leverages, which may serve as strategy entry points. Furthermore, the strategies are evaluated and harmonized, taking into account a multitude of criteria. So, just like an early warning system in a car, Marisco equips conservation practitioners with all the necessary means to detect potential future risks, enabling them to react in time. In practice, risk management prepares us for some of the major challenges lying ahead. But of course, there may still be some unwanted surprises.